This is for your talk methods, the continuation of Northern Hemisphere 2019, question 4. We're up to E, find the smallest value of A for the condition. So Mr. Neg does not want his property to be mined from further than 4. So this is Mr. Neg. That point there has to be limited to 4. And this A value is the first stationary point, and it's going to be this value here, but the negative of the square roots. So if I put this into this function, so P of that value has to equal 4 and solve for A, that should give me that answer. I've looked up there, Mr. Neg's down here, so it's actually Miss Potts' property up there, so we're wanting this to be -4. Therefore, what I'm going to do is to make that -4, which means on my calculator, if I put that to be -4 and execute, I end up with what I need for that one to be the positive square root, and I get 0.716 for the value of A. Okay, to do part F, find the value for A for which the total area mined is minimum. I can't make the assumption, like in A, that these were equal. These were only equal because these were the same distance apart. Now that we have our new function, when A is equal to 1, then they're the same distance apart, otherwise they're different. So I need to do two separate integrals, and I need to go from 0 to 4 minus 4 on top of 1 plus A, of P of x dx plus the integral of up to 4 of 4 plus minus 4 on 1 plus A of P of x dx to get an expression for the area. Then I need to take the derivative of that with respect to x and set it equal to 0. So I'll do that on my calculator. There to there of f of x gives that expression with that answer. It's all in terms of A, so I now take the derivative with respect to A. Set equal to 0 and solve for A. Execute, and I get A equaling 1 for these two values. Equals 1. And the mining company. Mining offers to pay Ms. Potts $120,000 and Mr. Neg $100,000. Maximise the area. Okay, so the cost is going to be for Ms. Potts' component times that, Mr. Neg's component times that. So Ms. Potts' component is the area to the top. So I want to take that and times it by 120,000. X. And we're going to solve that for, take the derivative and set it equal to 0 and solve for A. My answer, its derivative with respect to A, set it equal to 0, and solve for A. And I'm looking for 3 decimal places, so I'm going for the positive because A has to be positive, 0.886.